Hey everyone, welcome to the ultimate high-yield masterclass for Geography Chapter 26, India, Mineral and Power Resources. Look, I know you're 10 standard students, I know the board exams are incredibly competitive, and I know the pressure is really on right now. But don't worry, today we're going to decode exactly what the examiners are looking for step by step. By the end of this explainer, you're going to have the highest scoring concepts absolutely locked in. So grab your notebooks, take a deep breath, and let's dive right into this. Here's our game plan for today. We'll start with an intro to minerals, move into ferrous metals, then check out non-ferrous and precious minerals. After that, we hit conventional power, shift into atomic and non-conventional energy, and finally, we'll wrap up with remedies for energy scarcity. All right, part 1, an intro to India's minerals. Okay, right out of the gate, we have a highly probable one-mark board exam question. Examiners absolutely love testing definitions, so you want to memorize this word for word from your textbook. A mineral is a compound of naturally available substances with a specific chemical composition. Got it? And how do we actually get them? Through mining, which is literally just the process of extracting these minerals from the earth. Lock those two definitions in your brain right now.
Moving right along to part 2, ferrous metals, specifically iron and manganese.
These ferrous metals are the heavy hitters of the economy, making up about 20% of the country's total mineral production value. So the absolutely crucial point here is knowing your types of iron ore, which are classified based on their metal and impurity content. Ready for a massive cheat code for the exam hall? Just remember the letters M, H, L, S. Say it with me. M, H, L, S. Magnetite, hematite, limonite, and siderite. Just write down MHLS in the margin of your paper, and the examiner is going to wonder how you remembered it all so perfectly. Okay, listen up. Red alert. This right here is a really common student mistake, and I want to actively warn you about this trap because so many students lose easy marks here. Do not confuse ferrous and non-ferrous minerals. Ferrous simply means it contains iron. Your ferrous minerals are iron ore and manganese. Actually, scratch that, manganese is technically a ferroalloy metal used for making steel and even dry batteries. On the flip side, your non-ferrous minerals are bauxite and mica. Keep those two groups strictly separated in your mind. Geographically speaking, these ferrous metals are mostly hanging out on the eastern side of India. I want you to mentally highlight Odisha, Jharkhand, and Karnataka. These specific states have the maximum iron ore deposits in the entire country. Visualizing where these are on the map is going to totally save you when you need to list major producing states. All right, Section 3, non-ferrous and precious minerals. Let's get into bauxite, mica, and gold. Let's talk bauxite. Picture a sticky brownish-yellow clay. That clay contains 60 to 70% aluminum oxide. Now, underline this phrase in your mind, wonder metal of the 20th century. This is a huge favorite for the examiners. When they ask you why it's called the wonder metal, you tell them it's because it's the main ore used to obtain aluminum, which is a metal with a huge, incredibly diverse variety of uses. Next up is mica, or as it's famously called in Canada, kage bangara. It's this really cool, transparent, heat-resistant, shiny silicate mineral. Now here is an exact previous year board exam question for you. Why is India's export volume of mica reducing today? The exact answer you must write down is because of the availability of substitutes for mica. Write that down, internalize it, it's a guaranteed mark if it shows up. Jumping back to the geography of it all, remember Odisha? It's incredibly important, again, because it is the absolute biggest producer of bauxite in India. And if we travel down south to Karnataka, you'll find Hadi. Definitely note this down. Hadi is currently the largest producer of gold in the entire country. Part 4, conventional power. We're talking coal and petroleum. Let's do a quick mental whiteboard sketch of how coal is actually formed. Imagine drawing a massive, incredibly thick, dense forest from millions of years ago. Next, sketch heavy layers of dirt and earth slowly stacking on top, burying those forests deep, deep underground. Then apply intense heat and pressure over millions of years. The result? All that buried organic matter gets completely converted into coal. Because of how incredibly useful it is, and we're talking not just for energy, but for explosives, artificial rubber, plastics, and fertilizers, coal gets a very famous, very cool nickname. Lock the term black diamond in your mind for the exam. Oh, and bonus fact, India ranks 3rd in the world in coal production. Just like with iron ore, you've got to know your types of coal. which are based on their carbon content and calorific value. So it's mnemonic time again. ABLP. Anthracite, bituminous, lignite, peat. Say it out loud right now. ABLP. This is going to help you rapidly recall the 4 types when you're staring down that exam paper.
So if coal is the black diamond, petroleum is undeniably the liquid gold. Why does it get this highly tested nickname? Well, because it is literally precious in both times of peace and war. It's an energy resource and a vital raw material that completely powers our agriculture, our industry, and all of our transportation.
Okay, I need you to pay super close attention here because examiners love to set a trap with this one. If they ask where petroleum was first discovered in India, the answer is Digboy in Assam. But if they ask for the biggest oil deposit in India, the answer is Bombay High, which is an offshore field discovered way later in 1974. First versus biggest. Digboy is first, Bombay High is biggest. Do not mix those two up. To map this out in your mind, if you scan the Damodar River Valley on the eastern side of India, that's your main hub for coal deposits in states like Jharkhand and Chhattisgarh. And then over on the west, off the coast of Maharashtra, that's where you'll find Bombay High for our largest petroleum production. Moving on to Section 5, Atomic and Non-Conventional Energy. Let's break down these atomic minerals systematically. For uranium, remember the monazite sands of the Kerala coasts. Thorium is also found in Kerala, plus Bihar and Tamil Nadu. Now, pay attention to beryllium. This is a high-value detail. Beryllium oxide is specifically used as a catalyst or a moderator in nuclear reactors. Examiners love asking about moderators. And finally, lithium is abundant in Jharkhand and Madhya Pradesh. So why the massive push to shift towards things like solar and wind power? Well, it's basic cause and effect. Conventional sources like coal and oil are exhaustible, meaning they'll run out, and burning them leads directly to the greenhouse effect and global warming. Because of our massive population increase and urbanization, we absolutely have to shift to non-conventional sources. Why? Because they are inexhaustible and they preserve our environmental stability. And finally, Section 6, Energy Scarcity Remedies. For the exam, you absolutely need to lock in at least 4 of these remedies to secure full marks on a long answer question. Ready? We must use non-conventional resources, give major importance to hydroelectric power, utilize alternate local energy, actively educate people to reduce their energy use, and innovatively produce energy from solid waste. Drill these bullet points into your memory. And just like that, you've mastered it. You now know the ins and outs of minerals, coal, oil, and green energy for India. Keep revising those mnemonics like MHLS and ABLP, and I know you're going to absolutely dominate your board exams. But before you go, I want you to think about this. If all our conventional fuels completely vanish tomorrow, which of these non-conventional energy sources do you think would single-handedly save India's future? Keep exploring that idea, keep studying hard, and I'll catch you in the next explainer.